Guys, a lot of people mentioned me in this one. Let's do it. They want to know what is the area of this blue region. Let's cut this in half horizontally and half vertically. This distance right here is going to be half of the 10 centimeters to give us 5 centimeters. Looking at this, the blue region is only in this lower left quadrant. So I'm going to focus on the lower quadrant. This down here will also be 5 centimeters. Let's zoom in on this quadrant. Let's color this quarter circle red and this other circle green. We know that the red quarter circle plus the green circle plus the area of the blue region, which I'll call blue X, is equal to this entire square. The area of a circle is pi r squared. The area of a quarter circle is pi r squared over 4. The area of the square right here is 5 times 5, and we can just copy down the x. This side of the square is the same thing as the radius of the quarter circle, so we can change this r down here into a 5. 5 squared is equal to 25, and we can rewrite this as 25 pi over 4. Next, let's drop down a yellow diagonal, and let's call the total length of the diagonal c. This c makes an isosceles right triangle right here, so we can use the Pythagorean theorem. This side here is equal to 5, so we can change the a to 5. This side is equal to 5, so we can change the b to 5. Both of these 5 squares are equal to 25, and 25 plus 25 is equal to 50. Take the root of both sides, and we get c is equal to root 50. We could simplify this into 5 root 2, but I'm going to leave it as root 50 for now. Let's change the label up here. Let's get rid of this. Now let's focus on the radius of this green circle. I'll call it a green r, and I'll mark it with a pink radius right here. And this radius right here would also be equal to green r. Let's take this radius, bring it down here, and let's complete this right triangle, and let's call the hypotenuse m. So we have another Pythagorean theorem going on here. It's going to be r squared plus r squared equals m squared. R squared plus r squared is equal to 2r squared. If we take the square root of both sides, we can split this up into root 2 times root r squared, and root r squared is equal to r, and the right hand side is going to be equal to pink m. Let's smush everything together, get rid of this, and drag this up here. So we know that this pink m plus the green r plus 5 has to be equal to this whole yellow line, which is root 50. I know that m is equal to root 2r, so I'm going to substitute in the place of this m a root 2r. Let's get rid of this now and drag this up. We can subtract 5 from both sides, and we get this is equal to this. Scoot this over, and we can see both of these have a common term of r, so let's factor out that r. R times what gives us root 2r, that's root 2. R times what gives us r, that's 1. And we can bring down the right hand side. Since we want to solve for r, let's divide both sides by this. These cancel each other out, so we're just left with r equals all of this. Let's get rid of all this work and drag this up. Right now we have a radical in the denominator. We usually don't like that, so we're going to multiply top and bottom by the conjugate of the bottom. That's root 2 minus 1. Root 50 times root 2 is root 100. Root 50 times negative 1 is negative root 50. Negative 5 times root 2 is negative 5 root 2. And negative 5 times negative 1 is equal to positive 5. Root 2 times root 2 is equal to 2. Root 2 times negative 1 is 1 times root 2 is equal, and 1 times negative 1 is equal to negative 1. Square root of 100 is equal to 10, and 10 plus 5 is equal to 15. Root 50 can be simplified into 5 root 2, and then these can be combined to give us negative 10 root 2. On the bottom, these two terms match, 1 negative, 1 positive, so they get rid of each other, and 2 minus 1 is equal to 1. So we don't need the denominator anymore. So now we have solved for green r. It's equal to 15 minus 10 root 2. Let's get rid of this stuff, and let's bring this thing down. And we'll leave some space because in the place of the green r, we're going to plug in 15 minus 10 root 2. So this thing needs to get multiplied by itself, so it gives us this here. And then we can multiply this out. It looks like this. 225 plus 200 is 425, and this minus this is negative 300 root 2. We can distribute this pi to both of these terms. Let's get rid of this, and now we have our area of our green circle. And then this right here is the area of the red quarter circle. This is approximately 2.312, where this is approximately 19.635. So now let's take both of these and add them to the x, and that's going to be equal to 5 times 5, which is 25. 25 over 4 is 6.25, and we can combine both of these to give us 431.25 pi. And now we're able to solve for the blue x. It's equal to this 25 minus this piece here plus this piece here. So this is the exact value of the area in units squared. And here it is as an approximation. How exciting.